expression for conservation of energy to find the equation for the maximum speed of an oscillator. And this means an oscillator moving in simple harmonic motion. So let's think about this, conservation of energy. We know that mechanical energy is kinetic energy plus potential energy. So in general, for an oscillator, the energy is the kinetic, that's a half mv squared, plus the potential, that's a half kx squared. So there's one expression for our energy. If the oscillator is at the equilibrium, we know that the position equals 0 and the velocity is a maximum, so that our energy is 1/2 times m times v maximum squared. Put in x equals 0, we get 0 for the potential energy. And if the oscillator is at the amplitude, then x equals a for amplitude and v equals 0 because it turns around at the amplitude. So E is a half mv squared, but v is 0, so the kinetic is 0 plus a half times k times x squared, which is a squared. Okay, so there's our energy. Conservation of energy means that these three guys are equal. The question asks us to find the expression for V maximum. So V maximum equals. So let's use this term, and what will we equate it to? We could equate it to this one, but let's use this one instead because the amplitude is often something we know about an oscillation. So conservation of energy means that 1/2 times m times v maximum squared equals 1/2 times k times a squared. Right off the bat, we can cancel those halves. Let's divide both sides by mass to get v maximum squared equals k over m times a squared. Take the square root of both sides to see that v maximum is the square root of k over m times a squared. So v maximum is the square root of k over m. Square root of a squared is just a. We're looking at this here, and we remember that the angular frequency omega is root k over m. So v maximum equals omega times the amplitude. Same expression that we got when we considered that the velocity of the simple harmonic motion went as a sine function. So there's our expression for maximum speed.